In this video, we will implement Python code to apply lipstick color primarily using Dlib for face recognition and OpenCV fill polygon to detect the region of an image that depicts the lips. We will be using an image of a human face for testing our implementation. Dlib get_frontal_face_detector is used to return Dlib's face detector, and Dlib shape predictor object is used to output a set of point locations that define the pose of the face image. I have used this shape_predictor_68_face_landmarks.dat face prediction model to create the predictor object, which outputs a set of 68 point locations. This part of the code is already implemented in the notebook and is not explained further in this video. Let's dive straight into the implementation for applying lipstick color to an image. We use the previously instantiated face detector object to obtain Dlib's face detection. We use the Dlib landmark detector object to predict the shape of a human face, that is, obtain a set of 68 point landmark locations which defines the pose of the supplied image. We're interested in facial landmarks up to number 68, therefore we'll loop through these landmark points to obtain their XY coordinates and store them in an array called lip points. Next, we supply this array to function create histogram of HSV in lip region. Before proceeding, we convert the image to grayscale, as this sometimes makes the task of creating image masks simpler. Our mask is identical in shape to the gray image array. We use CV2 fill poly to create a polygon for the lip region using the supplied landmark coordinate. This sets the pixels in the enclosed polygon to 255, 255, 255 in BGR scale to set a pure white color for the area enclosed by the polygon, and sets the pixel values for the rest of the mask array to 0 or pure black. Next, we apply the mask to the gray image array using bitwise AND operation, which has the effect of retaining the gray image's pixel values in the lip area while setting the other pixels to 0. We will shortly see why we set our gray image this way, but before that, a quick word on why OpenCV's fill poly function works really well for our requirement. Our OpenCV's fill poly function generates a polygon that approximates the area enclosed by the lip landmark points. Our implementation uses the area enclosed by this polygon to identify the pixels in the region. Using the HSV, that is hue saturation value color model, the hue component of these pixels is shifted towards the lipstick color of choice. The saturation and value components are also adjusted to provide a more realistic appearance to the applied lipstick color. Now back to the implementation. We apply a Gaussian blur to smoothen out the lip mask in the gray image. This should give our final image a more natural look after blending. The gray image that we set previously with a mask can now be used to filter out the pixel indexes in the image array corresponding to the lip region. np.where function returns us the indexes of all the pixels that are not black, that is within the lip polygon area. We stored these indexes in lip_pixel_index. Next, we convert the original BGR image array to HSV model and split it into individual hue, saturation, and intensity or value channels. We extract a vector of pixel hue values from the H channel indexed by values in lip_pixel_index. Likewise, we extract vectors of pixel saturation and intensity values from S and V channels respectively. Then we construct NumPy histograms for each of these three vectors. The bin values I set for hue, saturation, and intensity or value were after some experimentation with the original image array. We returned the three histograms and the lip pixel vectors and indices from this function. Next, we call the function change HSV of histogram and pass our three H, S, and V histograms, the lip pixel vectors, and pixel indices to the function. In order to change the lip pixel color to a hue of choice in this function, we create three NumPy arrays with hue, saturation, and intensity values respectively that we want to replace the original pixel value with. The NumPy arrange function returns a NumPy array with evenly spaced values within supplied intervals. For the required lipstick color, I have set specific interval values for hue, saturation, and intensity, which I determined after some experimentation. The main hue, saturation, and intensity pixel values of the lip region of the original image have the highest frequencies in the HSV histograms. We try to pick up to 40 consecutive highest frequencies of the original HSV values in the function getLargestAdjacent frequencies. Numbins is the parameter to set how many consecutive highest frequencies we want. The function basically sorts the histogram in descending order to capture the indexes of the highest 40 frequencies. These indexes are nothing but actual pixel values in the HSV vectors. Using these values, we do a reverse lookup to find corresponding indices in the HSV vectors. We then replace the HSV pixel value at those indices with values for the intended lipstick color and propagate the changes to the HSV image arrays. This has the effect of applying the intended lipstick color. Finally, we display the new image array after merging the replaced HSV channels that contain the replaced pixel values for the lips. This completes the implementation. We hope you like our video.